Good afternoon, everyone. I hope you are doing very well. The last part in chapter 6 was related to the type of the beddings for the sewers. As you know, we learned about how to design the sewers, and we learned how to find the invert level of the sewers and the distance between the manholes, and how to find the acceptable or relatively the slope of the sewer themselves. And the last part in this chapter is how to find a proper bedding for the sewers. As you know, here we have the sewers usually will be look like this. Such kind of the sewers, and if I wanna draw the if I have, for example, this was a bed of the bedding of the sewer. If I have, for example, here's what the section, cross section of the sewers means by, if I have something like that, and let's say this is the bedding, or this is this is the trench that we should put the sewer itself. So it means that between the manholes we have to cover that sewer. This is the sewer itself. So this is the sewer, and this is the trench. The trench is used to fill the cover the So this is the trench, and it's used to cover the sewer itself. So we have something like that. This is the sewer itself. Now what should we do? We have to use a kind. There's a type of the bedding. I mean by the bedding, I mean how do we have to have the layout of the sewer? Should we put the sewer itself on the ground? This is the bedding. And by the way, this trench has a width. This is the width of the trench, and this is the depth. And when I say the depth, here's the depth. H is the depth. The depth is the depth of the trench till the crown of the till the crown of the sewer itself. So this is will called as an H. So this is the H, and this is the width, which is called B. So the dimensions of B and H. By the way, H, we have to have it from the design of the sewer. So you remember that when we say that there is a manhole here, when we say that there is a manhole here, so this should be the manhole, and we say that there is another manhole here, and the sewer will be here. So usually we will put, and we will go with the minimum slope at least, and we have some kind of this is, if I want to take a section anywhere here, so the section will be here, it will be represented by this one. So the depth of the sewer will be how much is we have to cover, we have to bed this sewer, we have to fill this trench by this kind of materials that we have. Now the question is, do we have a standard bedding? Yes, we have a standard, and within the limit that we have. Some of the beddings are asking to just lay out the sewer on the bed after excavating. Just put it here, and then well compacted soil, and just put it, and carefully we have to fill sand here. And after sand there will be a 30 centimeter again fillings. Then after that there will be ordinary filling, and there is another kind of bedding. And the standard bedding that we have to go with those kinds of bedding. The first one, it's called Class A bedding, Class B bedding, Class C bedding, and Class D bedding. It means that you are, as an engineer, you have to make your design, and after filling the design, after finalizing the design, you have to decide where is the bedding of the sewer should be. So in somewhere we should have, for example, in the same example that we say here, we may have from here to there, we say that the class, for example, D is required bedding. So it means that you have to go with the class D. For example, in this part, till this part, we may have a class A bedding. And you may ask, how should we decide where is to put a design A and where is the design D? And what is the difference between them? The difference between design A and Class B bedding is the load on the it's called load factor. The load factor is we have to use, for example, Class A for if we have a load factor on this between 2.2 to 3.4, and I will come with these numbers. What are they mean? And now Class A is when we have, for example, when we have a high pressure on this pipe, so we should put the sewer itself. Here's the sewer, and here's the depth of the, and we should put at least minimum 1/4 of the inside diameter. For example, if you have 200 millimeters pipe sewer diameter, so you should take 1/4 of the 200, means 15 millimeters, 5 centimeters concrete, plus at least the width of this. For example, if I have 1.2 meters width of the trench, so also 1/2 divided by 4 will come with 30 centimeters. So we have to say 30 centimeters. Here should be here's we have a plain concrete. This is called concrete. We have to make fill here. We have to put 1/4. It means that 50 centimeters here we need concrete, and after 50 centimeter we have to put the sewer, and then we have to fill at least the sides of the sewer till the depth of 30 centimeters plain concrete. Then after that we come and we will fill the rest area, and this is called concrete cradle. Concrete cradle bedding, it means look like cradle. So concrete cradle bedding, it will used for if you have a load factor between 2.2 and 3.4. This is the range. So you have to first to calculate the load factor, and when we have calculated this one, and based on this load factor, we will decide on which kind or which type of the bedding of the sewer should we use. You have load factor, high load factor, low and medium, and this is the load factor. So let's come with the load factor. What's the load factor means? The load factor, exactly, it means that how much is the load that we have, linear load on the pipe. So how many that we have, for example, if this is a pipe, how much is the load that's acting on this sewer? How many Newton per meter? How many kilogram per meter length of the pipe will come on this sewer? And this will be we should know how much is the depth of the filling on that pipe, and I will multiply it, and I know the gamma. The gamma is how many kilogram per meter cube. It means how much is the density of the raw material that will be filling material that will act on this pipe till the this crown. So I will multiply this gamma by the area of the trench, then it will give me how much is the load that will act on this pipe per 1 meter length of this pipe. This is 1. Divide, and this is should be what? This is should be divided by, and how much is the strength? The strength of this pipe, of this sewer. Now we have to know what is the capacity of that. It will crushing strength, crushing strength of this sewer, how much it will be. When we buy this sewer from the manufacturer, they will tell me, or they will tell you that this diameter of this sewer will have a crushing strength. So a crushing strength means how much is the megapascal, or how much kilo 1 meter of this pipe will be capable to be loaded until it will get crushed. Now dividing that load on the crash will give you a load factor. In case that we have higher load divided by the crushing, it means that we have a depth of the fill-in for high value, and it will exceed the crushing strength by 2 times. For example, here 2.2 times till 3. So it means that you have a huge load on this. It will be exceed the maximum crushing strength. In this case, what we should do, we should strengthening the sewer itself. So how to strengthen the capacity of the sewer? We will put concrete here and somewhere else. And we have for this kind of the load factor, which is 1.1, it means exactly the load on this sewer will become equal to the crushing strength. Then we may use the normal bedding, which is like this. Now of course we will not use the crushing strength directly what I from the source. What I will do, I will use a factor of safety. I will use factor of safety. What I will do, for example, I will get, for example, if I have a table for the capacity, and this is from ASTM, which is American Standard for, this is ASTM. ASTM tell us the pipes, the diameter of the, for example, 24-inch diameter. We have the extra strength clay pipe, and by the way, clay pipe and concrete pipe are the same one. So for having a sewer of 24-inch diameter, which is about 610 millimeters diameter, this 1 meter of this pipe has a regular 6,550 kilogram force per 1 meter. It means that upon having 6,550 kilogram, this pipe, and this is the pipe, when I load on this 1 meter length, this is 1 meter length. When I used a load on this pipe for about 6,550 kilogram per meter length of this pipe, so this is will be the capacity, or this is the crushing strength. Now what I should do when I'm going to use this one for calculating the load factor, I will not use the same value, but I will use a factor of safety. I will say if I have a factor of safety equal to 1.5, for example. So instead I will instead of saying that this 1 meter of this concrete can hold 6,550, I will say it can hold, or it can capable to be crushed for less than this one. For example, if I am using factor of safety, will be the crushing strength. So what I should do, I will, instead of saying that this 1 meter it will capable of loading 6,550, I will divide this one by 1.5. I will say, okay, this 1 meter it will be crushed up upon using 4,366.67 kilogram per meter. Now this is more safer. It means that I will use, instead of when I'm going to calculate the load factor, I will use this value, this crushing strength. So I will say load factor, it will be equal to the load or applied load or crush divided by crushing load, which is here crushing load is the one that from table divided by factor of safety. So instead of saying this is 6,550, I will not say that. I will say that it will not should be 4,366.67 kilogram per meter. Then this is just for the capacity or the capability of this pipe. Now this is what related to the pipe itself. What related to the applied load, it means the load that's coming for the filling of this trench by trench. How much is the load that is coming on this pipe? We say that this load, this is will called as a W. I will name it as a W. This W is coming from the filling. And by the way, it's not just the filling, it will be the filling and fillings and also lateral pressure that we can cause a kind of effect on this load. So for this load, what we should do, we will just use this equation. The W is the loads that we have upon the sewer. It is equal to the C. Where is the C? The C a coefficient times the omega, or which is the density of the filling material. Oh, and this is depend on which kind of soil that you are using or which kind of filling material you are using to fill this trench. We have for a certain time, we have for example, if I am using just the sand, so you know, for dry sand, the gamma that the density of this material will be 1,600 kilogram per meter cube. It means 1 meter cube of the sand that will be used for filling will have a load of 1.6 tons. Now usually we have, if you are using the clay in our climate, we are using the clay or the soil, so you can be aware that it will not be more than 2 tons, 2.08 tons per meter cube. That is in worst condition. So worst condition is this, and you have to use that one in wet climatic conditions. Otherwise you can have these numbers. Now back to the equation. So this is the C and this is the kilogram per meter cube. Let me say that if I'm using clay, so it will be 2080 kilogram per meter cube. This will be multiplied by the B, and the B here is the width of this trench. Now times the B square, it means it will be meter square, and there will be kilogram per meter. So the W and C will be factorless, unitless, and then I will get the W in kilogram per meter length of this pipe. I will divide this one by the crushing strength of the pipe, and I mean by the crushing after factorizing the crushing strength, after making less available on what is in the table. Now you may ask, where is the depth? where is the depth of this will affect on the W or not. The value or the C value is will tell us that yes, the depth will affect on this one. So H is the depth and W is the width. So H over B, this is a term that used in the calculating the CU. It will be meter per meter, so it will be unitless. And here we have this equation. Ku is the Ku bar. K is a coefficient for lateral pressure, or divided by vertical pressure. I mean by lateral earth pressure by vertical earth pressure. K divided by this one. So what should we do? We have to have this K, and U bar is the sliding factor between the trench, the soil, the trench itself, and the filling material. So when we have a soil that's used for filling this trench, and we have the original trench soil, so we have two soil, there will be a factor between them. This is called U bar. Now, as a summary for the K times U bar, it's called KU bar. We have the table. This is the table of the KU bar. Maximum value, I mean by the KU bar, the maximum value available for the KU bar for cohesionless granular material, it means for gravel, for example, and so on. We can use 0.19, and it's basically the 0.1 KU bar. It will range between 0.11 till 0.16. You can see 0.11 till 0.19, sorry. So usually you can use the KU bar that we have based on this one. For saturated topsoil, for clay is 0.13. So what should we do? We have this one from this table, and the H over B is the dimension of the trench, and the KU also from this table. I will get the value of C. So here, yes, the H over B will affect on this value of C, and then this C will affect on the W. So the H, the depth, is affect on the calculating the W indirectly. Now I will summarize all the given materials as in the following. So first of all, we should the classes that we have of sewer bedding. We have class A till class D, and the classes will be based on the load factors. Based on the load factor that we have, it will be class A high load factor 2.2 and 3.8, and class A D is 1.1 load factor. Now, so when we need to decide which class should we use, so we should know what is the load factor, and after the typical one classes is here, the typical drawing of the classes. Now, how to calculate the load factor? So for load factors, we say that this is equal to the load on the sewer divided by the crushing strength of the sewer, and this crushing strength, it will be factorized. It means I will divide this one by factor of safety. For example, factor of safety for the sewers will be 1.522. So and this load on the sewer will be called as a W. So W divided by the crushing strength of the sewer. This is from table. From ASTM, American Standard Method Testing Material. American Standards for Testing Material. Now, how to calculate this W, which is the load for on the sewer? It will be W. It will equal to C density times B square. Here the W is the rho or density of the filling on the sewer. So it means that how much it will be, how much if you have a sewer here. So the filling material, for example, here is the material, the fillings. So what is the rho? How much is the kilogram per meter cube it will be? This is called W, small w. And B, we said the B is the width of the trench, which is equal to B. And usually this B will be, by the way, B is the diameter of the pipe plus, I think, minimum 8 inches. So yeah, there is an equation for this one, but at least it should be diameter plus something, the distance that we can, the laborers can work on this. Okay, now this is will be the W, and the H is the depth of the filling material until the cover of the sewer. Now, so for this C value, or this factor, will be equal to 1 minus exponential minus 2 KU bar H over B. We said the H is the depth, B is the width, and the KU bar is the product of what will be 0.11 till 0.19. This is the maximum value. K is the ratio of the lateral earth pressure to the vertical earth pressure, and U bar is the sliding factor between the two soils, one of the earth itself, the trench soil itself, and the other for the filling material. So we have 0.11 till 0.19. That will be the KU bar. So we can use this one. It will be unitless, and I will use it in calculating the W, and then it will be in kilogram per meter, then divided by the crushing. I will get the load factor. After that, I will decide which is the class that should I use it. Now I think we have an example on this. Yeah, here's the example. You can see there is the 24 inch. Here's the 24 inch. Okay, here's the 24 inch. 24 inch. Here's 24 inch sewer, so we have a 24 inch. This is the diameter of the sewer. I'm sorry for the terrible. So the diameter of the sewer is 610 millimeters, or it's 24 inch, and there will be placed in an ordinary trench. So ordinary trench, it means that the edge is 3.66 there. So here's the edge, 3.66 meter, and the width of this trench is 1.22 meter. So here's the filling that will be. This is the filling material. Will be backfilled or filled with wet clay. So you have to be aware for the wet clay. What is the wet clay? Raw. So wet clay, this is wet clay, because we need to know what is the wet clay is loading. From the table we can say here's the wet clay. Clay, for clay, Wet clay, here's the wet clay. So wet clay, we have the load, it will be 1920 kilogram per meter cube. So the W here's 1.920. 1,920 kilogram per meter cube is the density. Now I have, this is, remember this is will represent W, the ohmic. Now what should we do? We have to see what will be the crushing strength of this material, of this sewer. This sewer is 24. 24 inch, it means you have to find a table which of the pipe, the 24, and this will be placed in ordinary, so we should know what will be the, this is the, by the way, this is the given, this is the W. Okay, and we have to go with the pipe. So based on this table, this is the table. On this table we have 24 inch. This is the 24 inch pipe. So we have normal clay, and we have this one, which is the it's called standard strength clay. So I'm assuming that if I have normal clay or standard, if I'm using extra strength clay pipe, I am assuming that this will be used for extra if I'm used extra strengths. So it means that for 6,000, so for extra strength, sewer, so the crushing strength extra strength crushing strength of the pipe, of the 24 inch pipe, sewer pipe, will be equal to 6,550 kilogram per meter. This is what we have it. Now if I am using the factor of safety of equal to, for example, 1.5, then I will use this one. Then I can say the strength, or the crushing strength, is equal to 6,550 divided by 1.5. Then you can say it will be 6,550 divided by 1.5. What will be the result? The result will be 4,365 kilogram per meter. So this is the capacity of the sewer. Now what we have to find, what will be the strength of the pipe, or what will be the load on the pipe. Now for that reason I will use I will say, okay, so the W will equal to C times omega times B square. B is the width. And remember that there is so remember that the B is the width of them, and it's equal to how much? It will be equal to 1.22 meter. Now the omega, because it's a wet clay, and it's equal to 1920 kilogram per meter cube. Now I have this and this, so what will left is C. C is equal to 1 minus exponential minus Ku bar H over B. I think divided by Ku bar. Let me check the equation. Yeah, it's 2 Ku bar, not Ku bar. And for the clay, remember that we have a wet clay. The clay is the Ku bar. Here's the Ku bar for clay. It's 1.13. So we should use, this is 2 Ku bar, sorry. This is 2, and there's 2. So Ku bar, which is the product of K, which is the lateral earth pressure to the vertical earth pressure, and the U bar is the sliding factor. It's 0.13. This is for clay. So I can say the C is equal to 1 minus exponential minus 2 times 0.13 times the H over B. B, we say the B is equal to 1.22, but the H is 3.66 meter as it's given, I think. Yeah, H is the 3.66 meter. So what will be this one? It will be 3.66 meter divided by the B, which is 1.22 meter. You can see you have times 2 times 0.13. In this way I can say there is the value of C will be equal to what? 2 times 0.13 times 3.666 divided by 1.22, and then it's 0.7, so it's equal to 1 minus exponential of minus 0.78 divided by 26.26. I can say minus 1 divided by 0.26, so the result is equal to 2.083. Now the W, or the load that we have, it will be 2.083 times the weight of the 1920 kilogram per meter cube, and times the B square, which is 1.22 square. This is meter square, and then we will have in kilogram per meter is the, so what should we do? 1.22 square times 1920 times 2.083. So the load, it will be 5952.64. Now the load factor is then equal to what? And now the load factor is I can say a load factor is equal to the load on the pipe divided by crushing strength, and the load it will be 5952.64 kilogram per meter cube per meter length divided by the load. Where is the load? The load that we have from the table, the crushing load. There is here the crushing. It will be 4,366.65, 4,366. I think here's the 4,600. $366.65 or 4,003.65 kilogram per meter. So you can see 5952.64 divided by 4,366.65 will come to 1.36. This is the load factor. So then I can use class, I can say it's between class D and C. Yeah, so it will be between C and D. So I can say to use class C. Class C. Now this is in case that we are using which type? I'm using the type, so use class C. So remember that we used 6,000. This is in case that remember I'm using a sewer which is 24-inch, and this is extra strength. Extra strength pipe. But if you are using the standard, not the extra one, you should remember that it will be different. So we used extra strength, so that was the crushing stress 6,550. Now if I'm using and this is the standard, not the extra ones, so the standard strength of the clay pipe. So what will be happen here? This 3,870 kilogram per meter. This is the crushing strength, and if I am using a factor of safety of 1.5, then the crushing strength will become equal to 3,870 divided by 1.5, which is equal to 3,870 divided by 1.5. It will be equal to 2,580 kilogram per meter. So it means that when we are using the normal, if I'm using then I can have to recalculate the load factor. So load factor for this is for extra 24-inch strength pipe. For load factor for 24-inch normal or standard pipe, so what will be happen? The load factor will be the same load that we have, which is 2.64 kilogram per meter, divided by the crushing strength of the normal, and which is 2,580 kilogram per meter, what means the load factor will be equal 52.64 divided by 2580. You have to have 2.31. This is the load factor. Now 2.3 it means that you have to use another class. The class of 2.3 is here. Yeah, 2.3, here's the class of 2.3. 2.3, it means you have to use class A. Means what? Means you have to add concrete here, while for the class C we don't need to use concrete any. So you can see in class C we don't have any concrete, but for class D, A, we have to use at least 24 divided by 4, it means 6-inch depth plain concrete, and we have to use another concrete. So we have to put concrete, fill concrete on the bottom of the sewer, and that's because the previous 24-inch was extra, the strength was higher than, so no need for having a very strong bedding. But in the case that we have using the normal one, you have to use the class A, means the class A bedding. This is the today's it was for the sewer bedding of the sewers. I hope you carefully review this subject, and it was the final part of the chapter 6, and I will send you another video which is related to the chapter 7, the design of the plumbing system for the buildings. Thank you very much, and see you later. Bye bye.